First, we look at introduction. Background of study: the study aims to develop a novel and effective way to remove methylene blue from wastewater. Methylene blue is a common industrial dye that is toxic and harmful to the environment and human health. This study focuses on creating nanocomposites made from activated carbon and zinc oxide, which have shown promise in adsorption and photocatalysis. The study will investigate the combustion synthesis process of these nanocomposites and evaluate their effectiveness in degrading methylene blue. This research can contribute to the advancement of sustainable and cost-effective solutions for wastewater treatment. The problem statement highlights the need for more effective and sustainable methods for removing methylene blue. Current methods are often inefficient, unsustainable, and costly. The study aims to address the problem by investigating the combustion synthesis of activated carbon zinc oxide nanocomposites, specifically tailored for the degradation of methylene blue. This approach offers a novel and promising solution for addressing the environmental challenges posed by methylene blue. Significant study: the research addressed the critical issue of water pollution caused by industrial dyes like methylene blue. By developing efficient nanocomposites for dye degradation, it aims to contribute to the preservation of water quality and ecosystem health. The potential application of activated carbon zinc oxide nanocomposites in wastewater treatment presents a sustainable and cost-effective solution for dye removal. The study's findings could lead to the development of practical methods for treating industrial effluents and improving water quality. The research aimed to offer a viable technology for industries that generate dye-containing wastewater, mitigating environmental harm and complying with regulatory standards. The research objectives are to synthesize zinc oxide nanoparticles and zinc oxide activated carbon nanoparticles using self-propagating combustion method. Number two, to characterize both zinc oxide nanoparticles and zinc oxide activated carbon nanoparticles using thermogravimetry analysis (TGA), X-ray diffraction (SRD), scanning electron microscopy (SEM), energy dispersive X-ray analysis (EDX), and ultraviolet visible spectroscopy (UVVs). Number three, to study the photocatalytic process driven by zinc oxide nanoparticles and zinc oxide activated carbon nanoparticles for degradation of methylene blue. Literature review: the literature review highlights the challenges of removing methylene blue from wastewater, a common problem due to the dye's toxicity and persistence. It discusses the individual merits of activated carbon and zinc oxide as promising materials for environmental remediation, specifically their absorption and photocatalytic properties. However, it points out the lack of comprehensive research on the combustion synthesis of activated carbon zinc oxide nanocomposite tailored for methylene blue degradation. The review emphasized the need to understand the synthesis process, absorption, the nanocomposite structure, and evaluate its effectiveness in dye degradation. This research gap highlights the potential of activated carbon zinc oxide nanocomposite for studies the efficient wastewater treatment solution. addressing environmental and the need for efficient dye removal in industrial settings. Chapter 3: Methodology. The chemical used for this study involve activated carbon, zinc nitrate hexahydrate, deionized water, 3-ethanolamine, methylene blue, milky water, 2-propanol, and acetone. The apparatus used are hot plate, mortar and pestle, magnetic stirrer, crucible, beaker, sample bottle, and dropper. Synthesis of zinc oxide with activated carbon. Step 1. React zinc oxide nanoparticles and activated carbon in 500 ml flask. Step 2. Add milk water to the flask. Step 3. Ultracentrifuge the mixture for 30 minutes. Step 4. Filter and rinse with milk water. Step 5. Dry the sample at 100 degrees Celsius for 12 hours. And step 6. Calcination. Zinc oxide-based nanostructures are a promising materials for photocatalytic degradation of various substances. The mechanism involves the generation of electron hole pairs upon exposure to UV solar light. These pairs participate in a redox reaction, producing hydroxyl and superoxide radical and ions that degrade absorbed contaminants. However, zinc oxide suffers from a high rate of electron-hole recombination, limiting its efficiency. To improve performance, various techniques are used, including metal and non-metal doping, co-doping, composites, substitution, sensitization, and other methods. Metal doping enhances visible light absorption, reducing reduces recombination, and promotes hydroxyl radical formation. Non-metal doping improves activity by enhancing visible light absorption and altering the electronic and structure. Composites with other metal oxides can improve efficiency by enhancing charge separation and reducing photocorrosion. Chapter 4: Expected Result. The study aims to synthesize pure zinc oxide nanoparticles and zinc oxide activated carbon nanoparticles using a novel synthesis method. The self-propagating combustion technique and characterize these materials using a range of instruments including thermogravimetric analysis (TGA), X-ray diffraction (SRD), scanning electron microscopy (SEM), energy dispersive X-ray analysis (EDX), and ultraviolet visible spectroscopy (UVBs). The study also aims to uncover new insight into the photocatalytic process facilitated by zinc oxide nanoparticles and zinc oxide activated carbon nanoparticles process for methylene blue degradation, potentially leading to their effective application in future research endeavors.